This circuit setup using the Locktronics modular system is designed to measure currents and voltages in a simple series circuit with a 10 volt DC power supply, one LED as a load, electrical load, and one 270 ohm resistor as an electrical load. At the moment we've got a rapid 310 digital multimeter measuring 9.9 volts coming out of the power supply. Power supply on its screen says 10.1. So the first question would be, which meter, which indication is more accurate? We've got an analog voltmeter measuring the voltage across the 270 ohm resistor. Well, that's the difficulty with reading analog accurately. You need good eyesight and you need to be able to interpret the moving pointer across a screen. We're reading 7.7 volts on the analog meter for voltage across the 270 ohm resistor. On the AVO 8 we are reading 26 milliamps current flow going through the circuit. If we use Ohm's law to give an expected result of current from Ohm's law, we would anticipate, if we use the voltage across the resistor of 7.7 volts, we then divide that by 270 ohms to give us an anticipated 29 milliamps current flow through the circuit. Currently with the analog meter, the AVO 8, we're measuring a little bit underneath that. We're measuring about 26 milliamps and we're anticipating 29. One of my assistants will take out, Joe, take the leads out of the AVO 8 please.
That one?
No, the big one there. Take the leads out there. And what to do, just move the AVO 8 to one side. Right, bring one of those digital meters over please. So what we want to do is put one of the leads into common. Okay, the other lead goes into milliamps. Okay, so what we do is we need to be on amps, which we're on. We're on the 200 milli setting. We switch it on and we can see that we read 29.5. The test leads are being reversed because there's a minus sign to indicate that which direction the current is flowing, and what we're now reading off the rapid 310 digital multimeter is 29.5. so the digital current reading is spot on against the anticipated current from Ohm's law, 29 milliamps. The analog meter is reading slightly under. So the question is, for test and measurement, how do you know which meter is the most accurate? And the quick answer is you don't, unless the instruments have been calibrated. Digital meters work, they sample the value of voltage or current, they digitize that value and they do display that value as numerics on a screen. Everybody that can understand numerics will read the same value off the screen. Different people interpreting analog meters, on the other hand, it does take a bit more skill. Two different people may read slightly different values from the analog meter because you have to interpret the position of a moving pointer across a background screen, a printed scale, a printed screen, and it needs more operator input. Digital meters require battery power. They are a computer in order to work. Analog meters do not need power to function when they're measuring currents and voltage. They work by electromagnetic means. They work by magnetic fields that mechanically moves a pointer across the screen.